In the second numerical, we have a long straight wire which carries current. We have to calculate the magnitude of magnetic field at a point which is 20 centimeter away from the wire. So you can say that suppose if this is a wire which carries current, you have to find magnetic field at this point. Suppose the distance of this point is 20 centimeter from the wire. So here we will be using Ampere's circuitous law. So you can consider this to be your Ampere loop. This we have studied in topic 4.7. And you can see this as application of Ampere's circuitous law. So first we'll write down all the given quantities. So current is given, it is 35 ampere. Distance of the point where we need to calculate magnetic field from the wire is 20 centimeter. So that is, suppose R is equals to 20 centimeter. Again we'll convert it into meter. So it will be 20 into 10 raised to minus 2 meter. I need to calculate the magnetic field, and here the formula which we will be using is B is equals to mu 0 I upon 2 pi r. So I'll need the value of mu 0, it is 4 pi into 10 raised to minus 7. It may or may not be given in your question paper, so you need to remember this value. So now we'll substitute all the values. So after substituting all the values, your answer will turn out to be 3.5 into 10 raised to minus 5 Tesla. Now again in this question, we have a long straight wire which is placed in a horizontal plane and it carries a current of 50 ampere. The direction of current is from north to south. We have to calculate the magnitude and direction of magnetic field at a point which is 2.5 meter on the eastern side of the wire which is lying in the horizontal plane. So first of all, I'll just draw the figure. Suppose this is north and this is south. The north point actually is behind the plane of the page and the south point is actually here like this. So this point is north and this point is south, but as it is in horizontal plane we have placed it like this. Now direction of current is from north to south. So this is the direction of current. Now I'll draw the east-west direction. So this is east and this is west. The point is lying at 2.5 meter to the eastern side of this wire. So suppose this point, and this distance will be 2.5 meter. I need to calculate the magnitude of the magnetic field at this point. So again we will be using the topic Ampere's circuitous law, and by the application of Ampere's circuitous law we know that the formula is B is equals to mu 0 I upon 2 pi r, as we have used it in previous example, so you know it. First of all we'll write given quantities. So you can see here current is given, it is 50 ampere, and the distance of the point from the wire r, that is 2.5 meter. Now by the formula, B is equals to mu 0 I upon 2 pi r. Now as we substitute all the values in the formula and calculate it, the answer turns out to be 4 into 10 raised to minus 6 Tesla. So this is the magnitude of the magnetic field. But they have also asked you the direction of magnetic field. So for that you will be using right hand thumb rule. So for that, see, I told you that north is actually behind the plane of the page and south is here. So this is north and this is actually south. So the current is moving from north to south. The current is moving in this direction like this. So how to use the right hand thumb rule? You have to hold the wire in your right hand, put the thumb along the direction of current. So this is the direction of current, as this was north and this was south. So this thumb is aligned along the direction of current. Now you have to obtain the direction of magnetic field at this point. So just see on the eastern side. You can see that my fingers are moving in this direction. If I align my thumb here, then fingers are moving in this direction. But also you can see that the straight wire is along the horizontal plane. So if I align my hand in horizontal plane like this, so you can see that this end is north, this end is south. So now my thumb is along the direction of current. Just see my fingers on the eastern side. They are coming out of the plane of the page like this. So the direction of magnetic field is vertically upwards, coming out of the plane of page. Here we are given a horizontal overhead power line which carries a current of 90 amperes. So we can say that this is just a wire which carries current 90 ampere, and the direction of the current is from east to west. You have to calculate the direction and magnitude of the magnetic field at a point which is 1.5 meter below this wire. So first of all we'll construct figure for this. So if I draw the directions, then this is suppose north direction, this is suppose south, this is east, and this is west. Now here in our question The wire is aligned along east-west direction and current is also flowing from east to west. So I can say this is the direction of current. Now you have to find out the magnitude of the magnetic field below the wire at a point which is 1.5 meter away from the wire. So suppose this point is at a distance of 1.5 meter. So you need to calculate the value of magnetic field at this point. So basically the concept which we will be using here is Ampere's circuitous law. We have a straight current carrying wire, and because of this current carrying wire we have to calculate magnetic field at a point which is 1.5 meter away from it. So again, this is the question from topic 4.7. So first of all we'll write all the given quantities and then we'll write the formula B is equals to mu 0 I upon 2 pi r, which is the formula for magnetic field at this point. So after substituting all the values and calculating, you will be getting the answer as 1.2 into 10 raised to minus 5 Tesla. Now we obtained the value of magnetic field at this point, but we also want the direction of magnetic field. So again, as we did in previous example, we will be using right hand thumb rule. We'll hold this wire into a right hand and we'll align our thumb along the direction of current. Then the direction in which the finger curls will give you the direction of magnetic field. So suppose if you see, this is the current carrying wire and this is the direction of current. So I have to hold this wire in right hand and align thumb along the direction of current. Then here, the direction in which these fingers are moving will be giving me the direction of magnetic field. I have to calculate the direction of magnetic field just below the wire. So here, if we have the wire, then below the wire, you can see my fingers here, they are moving towards south direction. See, below the wire. So this is the wire and below the wire here, the fingers are along south direction. So I can say the direction of magnetic field below the wire is towards south at a point which is 1.5 meter away from the current carrying wire.